Hello and welcome to part 92. In this video, we will start understanding what is async and what is await keyword in C#. So let's try to understand what we can achieve using async and await keywords. So let's understand what is going on in this program. We have a long running task that is taking 5 seconds to complete. And if we use synchronous programming and run the program as it is, it will wait for 5 seconds, meaning the main thread will be blocked for 5 seconds. And after 5 seconds, we will see the message main thread completed. Let's run this program and see what is happening. So our program is waiting for 5 seconds, and after 5 seconds, we will see main thread is getting completed and we are seeing that output and program is getting terminated. Okay. Because we have called this method synchronously, that's why our main thread was blocked. One way to resolve this problem is by using threads that we have seen in previous videos, where we have used new threads and called the long running methods on that new thread so that we can make our main thread free, right? Using that technique, we were making our main thread non-blocking. Okay, async and await is the other way to achieve the same thing. There are a lot of differences between threads and async and await programming that we will understand in the future videos. But let's see how we can make this code non-blocking by using async and await keyword. Okay, so let's do one thing, remove this piece of code. And to create a async method, we need to use the async keyword. So let's use async keyword and let's for now remove this piece of code. If you notice here, our method is now async. Okay, and if I build my application, it will get built successfully. But if I have any code here, and if I run my long running task here and then print main thread completed, first of all, you can notice there is a green line. Green line means there is a warning. Let's understand why we are getting this warning. It says the async method lacks a wait operator, meaning if we don't use an await word in our async method, it will give us the warning. Because if we don't use await keyword, this method is going to run as a synchronous program. Let's see what I mean by synchronous program. Synchronous program means first this method will get complete and then only this main thread completed will be printed, meaning it will still be a blocking call. Let's run this program and see this in action. You can see here first long running task is getting completed and only after that we are seeing main thread completed. All right. So if we use async without any await keyword, that time C# will run the program as synchronous method. You can see this in the error message again here. If we don't use await keyword, then it will be running as a synchronous program, right? You can see here it will run synchronously. Okay. So if we are not using await keyword, there is no use of writing async programming. It will run as a asynchronous. So let's understand how we can use await keyword. So let's say our method is taking some 5 seconds to complete. So let's add task dot delay and let's say 5 seconds. Okay, and let's await for this task to complete, and let's await for this wait to complete by using the await keyword. Okay, and then print. And now try to run this program like this. Now we are using the await keyword. Await keyword is used to wait for the execution to complete. We will wait here for 5 seconds to complete and then only we will go to this line. But in this case, we will not block our main thread. Let's put a console.read line here. I will explain why we need to use console.read line in this case. Okay, but first now let's run the program as it is and see the behavior. Now you can see main thread is getting completed, meaning we have unblocked our main thread so that it can complete its task. right? And after 5 seconds, we are seeing long running task completed. So what happened here? Our long running task was executed asynchronously, meaning when you fire this method, the program will not wait for this to complete, right? It will go ahead and still complete this piece of code, and it will wait for the user's input here. Okay, and then when we are running this asynchronously, and when we said await keyword, C sharp will know I need to wait here for 5 seconds, and once 5 seconds are completed, that time I need to come back here and then execute this piece of code. Meaning what is happening here internally, C sharp will keep some pointers. Whenever we hit a wait keyword, it will keep a pointer of this location where we have this code, and once the task is completed, meaning once the delay here is completed, it can be delay, or I can call some API here, or I can call a open a database connection, or I can read a file here. This can be anything that will take time. Once that operation is completed, it will come back here and execute the piece of code which is written below it. All right. And the purpose of using console.readline is when we are using async and await keyword, it will not use threads, meaning there is only one thread to complete this whole process. This complete code will be running on a single thread, right? And if we don't put a console.readline, the main thread will get completed and there will be no thread left to run this piece of code. To avoid that, we have used console.readline so that we can keep our main thread running and wait for long running tasks to also get completed. If I remove this console.readline, let's see what will happen. You can notice here main thread is getting completed and program is already terminated, meaning there is no thread left to run this piece of code which will be executed after 5 seconds. That's why we need to put a console.readline there to make sure we have a thread available to run this piece of code. If I run the program again, you can see main thread is getting completed and we are waiting for 5 seconds, and once 5 seconds are completed, we are seeing long running task completed, right? So this is how we can use async and await keyword in C#. And guys, to prove that we are not using multi-threads when we are using async and await keyword, what you can do, we can put a breakpoint here and run this program in debug mode. Once you have hit this breakpoint, you can go to debug, Windows, and you can select the threads here. And what you will notice here, there is only one main thread. The other threads are also there, you can see here, but these are not the threads which are created by our program. From this window, you can clearly see there is only one thread that is created by our demo.string program. This is our program, right? And our program has only created one main thread. There is no additional thread on which we are running our long running task method. So all the methods, meaning all the code which we have written as part of this program, is getting run on a single thread. Okay. So this proves async and await programming will not use multiple threads. Instead, it will use a state machine. State machine meaning whenever we are hitting the await keyword, the C# will put a pointer here to make sure whenever this task is getting completed, it will come back to this piece of code and start executing from here. And that's it for this video, guys. In the next video, we will see how we can use async and await keywords by using some real-time examples.